Okay, yeah, so we're gonna start on this. Okay. Anjali, Kashyap, you can do let's investigate.
You have 4 identical squares. How many ways can you arrange them to make a symmetrical shape? 1, 2, 4. I could only think of 4. I mean 3.
Okay. So it says you have 4 identical squares. How many ways can you arrange them edge to edge to make a symmetrical shape? So we have a square, we have a rectangle, and
And the vertical rectangle.
the vertical rectangle.
Yeah.
Oh yeah, wait. Oh yeah, we have a vertical rectangle. Yeah, I agree with your answer. Okay, number 1 will be done by Ishwar.
Are we doing number 1?
Yeah, number 1. Hello, Ishwar?
Yeah, I'm doing it.
Oh, okay.
No, I would add it on. Do you see the L shape?
Yeah.
There's 3 dots in a row and 2 dots going up, right?
What do you mean?
I'll do it right there.
Oh, right here? Right here?
Yeah.
Yeah, I agree. Because if you do that, then you can split the square in half, and then identical and identical. So one symmetry line. So yeah, number 2 will be done by Johnny.
Yeah.
You can do number 2.
Okay, so this is a shape made from 4 regular triangles. Use a ruler to copy the shape. Draw one line of symmetry on the shape. Is this the only line of symmetry? I would say that the line of symmetry would be vertically, and I would say that it is because if you do it from any other like angle, then it still wouldn't be symmetrical.
Say that again?
You can only do it vertically.
Yes, I agree with only vertically because if you copy the shape right here, you can split it in half, and then if you split horizontally, then this one's
Or you could do diagonally, like from one corner to middle of the other corner.
No, you can't.
Like the one of the down corners to the middle of the side.
Let's check. Let me just zoom the recording. Okay, so number 3 will be done by. Wait a second. Okay. Number 3 will be done by Lochin.
Okay. Number 3 is copy and complete the diagram to make a shape that is symmetrical about the mirror line. Let's see. Copy and complete the So, didn't you already do this here?
No. This is. Wait a second. Oh, yeah. That was. That there. This was not. Oh.
The thing under that was also part of number 2.
I don't think so. I don't really think so. I don't think the number 2. I don't think under that was number 2. Oh, Lochin, you can do number 2. You can do number 2.
Me?
Yeah.
Okay. This is a made. This is a shape from 4 regular triangles.
Yeah.
Use a ruler to copy the shape. Draw one line of symmetry on the shape. Is that the only line of symmetry?
Okay. So.
I had already done this one and my answer was vertical.
But that's okay. Yep. I agree. You can also do 2.
Horizontal.
Yeah, you can't do horizontal. Look, you yourself. There's lots of echoing. Okay, so you can do vertically, and you can do diagonally like this, which is a very weird one, but that still works. And same for the other side. You can do like that, like that. That's another symmetrical line. See, when you split it here, these are the symmetrical shapes. When you split it here, these are the symmetrical shapes. And when you split it here, these are. So yeah, that's why there are 3 ways. And so I would say no. I know, I'm a weirdo. Because nobody would say no with lines. Okay, so the answer is
Which question are we on?
we're on the next page.
Because I just joined.
Oh, we're on the next page.
And are we on question 2?
No. We're on question 4.
Okay.
On page 65.
Okay.
Let's see, Neil, you can do 4.
Find all the different shapes in this pattern. Here's an example. Draw each shape. So, like, do I have to draw a shape?
5 different. Oh my gosh. Find all the different shapes in this pattern. No, you do not need to. Because I can do it.
Okay, so in this pattern,
Yep.
like, which one?
This. Number 4.
Okay, so in one of these squares, what is the different pattern?
So one's already done for you.
Oh. I don't really get it.
Okay, so it's basically saying what are the symmetrical lines. So if you split it right here, and then right here, you get this box, and this box, and this box, and this box. So,
Yeah.
so it's saying what other things can you get by splitting it in a different, way.
Oh, so what the same pattern you can get with a different shape?
No, it's basically saying like what other patterns are you gonna get with like different, ways.
Oh, so if you did it horizontally and vertically, that means you would have have 4 squares. But if you did it diagonally, then you would have lesser squares. You would actually have triangles because
There's like two triangles that are equal.
yeah,
And
you would have 2 triangles that are equal.
equilateral. No, they're not
Yeah.
supposed to be called. No, they are not called equilateral triangles. They're actually called isosceles triangles.
Oh, they are?
Yeah, they're not equilateral triangles.
Wait, what are they called?
They're called isosceles triangles.
Isosceles triangles?
Yeah, equilateral triangles have equal sides, like this one. This has all equal sides. But isosceles has only has only one pair of equal sides.
Oh, okay, yeah, now I get it. Thanks.
This is an isosceles because this is that's
So
different.
that's an isosceles triangle.
Yeah, and there's
It's not an isosceles. It's not an isosceles triangle. It's an isosceles triangle.
yeah. Keep on.
Isosceles triangle.
Yeah.
Okay.
There's also one that I forgot the name of that has no equal sides. I forgot.
Is it acute?
No, that's an angle. Q is an angle.
Yeah.
No, acute is also a triangle, like an acute triangle.
That's okay.
Yeah, there is a such thing as an acute triangle.
Oh, there is.
Yeah.
I haven't heard about it though. But okay. I didn't really know there was, but
Wait, you can also make that shape?
what? What shape? What shape?
The one that looks like a tooth.
A tooth.
The acute triangle.
Oh, this.
Yeah, that one.
You can't make that in this because this is. Well, yeah, you can't make it in this.
Yeah, you can't do that.
Yeah.
Okay. Yeah.
Okay, so C5 will be done by Sanjana. Hello, Sanjana? Yeah.
Is it number 5?
Yeah, number 5.
A sheet of paper is folded once. The shape is cut out as shown. Describe the shape that is cut out. So, well, it's like half a triangle folded.
No, it is a triangle, actually. Because see, so he folded.
Yeah, it is a triangle actually, but it's just different. I know that name kind of, but I kind of forgot it.
Yeah,
Okay, so see, this guy folded this paper and he cut out this shape. And since it's folded,
Oh wait, yeah, I think I know what shape triangle that is. I think I know the answer.
yeah, this is a equilateral triangle
Yeah, that's what I was gonna say. Equilateral triangle.
because since this is like since
This is like that, then the same side has to be like that. So yeah,
Yeah.
I think it's an equilateral triangle. Oh, and she also has to say how many line of symmetry it has.
Yeah, how many lines of symmetry does it have?
I think it has
Yeah.
2 lines of symmetry.
It has what?
2 lines of symmetry.
No, I disagree. I think it has one line of symmetry.
No, I disagree.
Yeah, I agree with Neil.
I think it has 3 lines of symmetry. So let's take our equilateral triangle right here. So first, it can be split vertically. Okay, so that's one. And then at this corner, we can make a line right here. So if you tilted this and made this corner the top, and you split it like this, and made it go to, and made this corner where it actually was.
But that's not equilateral. That's not equilateral.
And how is that not equilateral?
Cause like one side is bigger than the other.
So let's.
No, it isn't. It's all the sides are equal.
No, like if you do it diagonally, it won't be equal, because on the top, the left side is long, and the right side is short, and on the bottom, the left side is kind of like mediumish, and then the right side is big. So I don't think that's equal.
This is equal. I think. Okay, this is all equal. So you can split it vertically. And at this corner, you can split right here. That's going to be equal. And at this corner, you can do.
That doesn't look equal.
Well, imagine it was equal. You could cut this corner too.
Yeah, there's
Yeah, it's equal. It's equal, Neil.
That means it's only 2 lines of symmetry.
There's 1 line of symmetry, 2 lines, and 3 lines. So it's 3
There's
lines.
3 lines of symmetry.
Oh, okay.
Cut it horizontal. If you cut it
You
horizontal,
can't cut it horizontally.
yeah, because one side
Yes, you
is
can.
bigger.
You can do it diagonally.
Yeah.
Yeah, but you can't do it horizontally.
Yeah, horizontally is this way.
Yeah.
You can't do it
Yes.
because
Yeah,
the
you
bottom
can do it
is bigger
horizontally.
than the top. So that's why I would think it's 3 lines of symmetry. So yeah, this 6 will be done by Srijin.
Okay. So it says write down all the capital letters that have lines of symmetry. Some capital letters have more than one line of symmetry. Can you find some examples? Some
So like basically
alphabets
have
that
to
could
think
be
of the alphabet letters that have a line of
yes.
symmetry or more than line of symmetry.
Yeah. So I have some. I think one A would work because if you split it in half, it would be symmetrical.
Yeah, but would
B
you
would
split
work
it
because if you
vertically
split it
or
in half.
horizontally, diagonally, or
Yes.
all of them?
Let Srijin talk. So when you're like saying that it can be like cut symmetrically, you also have to tell them like which way. So A can
Oh, it can be cut like in half. It can be cut in half.
vertically.
Yes.
Yeah, it can be cut
vertically.
vertically.
Yes.
Vertically,
Yes.
top to bottom. Horizontally is side to side, and then diagonally is. I think you would know what diagonally is.
So A would go vertical. No, I mean A would go up.
Why did he mute?
I don't know. What the heck?
Say it again.
Vertically.
What? What did
A
you?
would go vertically.
Yeah.
B would go horizontally.
Yeah.
C would go horizontally.
C would go horizontally. Yeah.
E would go horizontally.
D would go horizontally. Yep, I agree.
E would go horizontally.
E would go horizontally. Yes, I agree. thing right here.
H would go vertically.
Yeah, and horizontally.
Yes. Yeah. I would go vertically and horizontally because you can fit in half and sideways.
Yeah.
M would go vertically.
What?
M would go vertically.
No, it wouldn't go. N wouldn't go. Because look, see? Oh no, I don't want text, I want the line to go. So you have N, if you draw an N, and that's an N. And so if you cut it vertically, then this, if you flip it, this side is going to be the straight one, and this side is going to be the horizontal one. But this side, but the others, but that has to be switched. And you can't. Oh yeah. So if you cut it horizontally, then this has to go diagonally. Wait. Actually. Yeah, I agree. I agree. I agree.
So we're on I. I would go vertically and horizontally because you can fit it in
Wait,
half
what's
and
for N? How would N go?
N would go vertically
How?
because you can split it in half.
But then one side will face up and then one side.
Yeah, you could go horizontal.
Look, see, this is
But you could go both ways, horizontal and vertical.
let's see. So
No, you can't do it horizontally.
yeah, you can't do it horizontally, but you can do it vertically.
Vertically, yes, you can do it vertically.
Actually, you can. Like if you just move the like horizontal cut up, it'll actually be identical.
What? Can you say that again?
So like if you move the horizontal line like more up, then I think it would be. Not from there. Like half.
Right here?
Yeah, right there. Right there.
Yeah, that would be because when you cut it horizontal, this side,
Actually, I think he's right.
what?
Yeah,
It can be cut horizontally.
yeah.
Yeah.
Just do it.
Yeah, see? It's
Yeah, that's
horizontal.
what I said in the first place.
Yeah,
Mhm.
see? It's good. So yeah, it's horizontally too.
So it has like a triangle shape and then a
Line.
vertical line, and then over here it has a triangle shape and a vertical line.
So yeah, that's
Yes,
why it would be
but-
horizontally.
guys, look, see. So this side has a point, and this side is open. This side has a point, and this side is open.
Well, if you look at it from a kind of different position, then you can actually see that it's symmetry.
Yeah, it's actually symmetric from horizontal.
Yeah, if you flip this side like the other way and then flip it, yes, it would be.
But then that's the same as doing it vertically.
Exactly.
So yeah, that means both of them are,
Yeah, it works horizontally.
What?
It works horizontally and vertically.
It won't?
It works horizontally and vertically.
Oh, you said
Yeah.
Yeah, I agree. Actually.
Yeah. Because like if you also do it vertically, the one side would be facing up and then the other side would be facing down. So that's the same thing with the horizontal.
Yeah, we wasted a lot of time on this question, so let's move on.
Yeah, let's just move on.
Susan?
Okay. O would go horizontally, vertically, and diagonally.
Yeah, I agree.
Yeah, I agree. O would go horizontally, vertically. Wait,
T would go vertically.
But I think N can go. I think N can go always horizontally, vertically, and
Yeah, and actually it would work. Yeah, it would go or is it diagonally too?
Yeah, it would also
And-
go that.
Yeah, we'll go diagonally too. Yeah.
Yeah. Okay.
And T would go vertically.
O would not go diagonally because see if you split O right here, this would
Oh, that doesn't.
That's vertically, not diagonally.
It could go diagonally.
Yeah, I think it
It
could.
can go
I think
diagonally.
it could.
Or it could go diagonally.
Yeah, it could go diagonally.
Yeah, it can because all sides look the same, so it could go diagonally.
Yeah.
Yeah, I think O can go diagonally.
Yeah,
O
Yeah,
is basically
too.
almost
Look
like a circle.
That looks like a rectangle.
I know. That's what I'm gonna change.
Well, O is supposed to be a circle, and a circle can basically go in any direction.
Yeah.
Yeah,
Yeah,
it
that's
can go in
more.
any direction.
Yeah, that's an wait. No, like yeah,
It looks like an oval
that's it. Yeah, that's
Yes.
circle.
That's O.
Yeah, I agree. It's a circle.
Okay. Yeah.
Go in any direction.
Yeah, O can. I just checked on my keyboard and tried it, and yeah, it can go diagonally.
Okay.
My keyboard has an O on it.
S would go vertically and horizontally.
I think S would go both ways.
Yeah, it would go vertically and horizontally
Yeah.
because if you split it in half,
You can't
It
do
looks-
it diagonally.
And diagonal. Yeah.
yeah, diagonally would work too.
Wait, it wouldn't.
Yeah.
Yeah, it would.
Let's.
Yeah, diagonally would work.
Yeah, diagonally.
Yeah.
So it's horizontally, vertically.
T would go vertically because you can't split it in half.
Yeah, I
Yeah,
think T would go vertically.
U would go vertically too.
I don't think P would go vertically.
I didn't say P. I
No,
said
that's the only option it could.
T. He said T.
I said T.
Oh, okay, yeah.
He would go vertically. U would go what is it? Vertically too.
Yeah.
And
E would go
diagonally.
vertically.
V?
V.
Yeah, V. Yeah, I agree.
W would go vertically.
Yeah.
X would go horizontally and vertically and diagonally.
Yeah, I agree.
And Y would go vertically and Z would go
I think Z will
Vertic-
go all directions.
yeah, because it's almost if you flip Z,
Yeah,
it looks
Z
like
would
a
go all
H,
there.
right?
It's the same as
So,
S. Z
N.
is the
It looks like
same
an
as
N.
S. So yeah, I think it's gonna be all of them.
Yeah.
Yeah, me too. Okay, so 7 will be done by who's next? Vishu.
Okay. So explore how you can cut a square shape from a piece of paper that is folded once. So it's like a backwards C. If you cut a backwards C, then it would become a square.
No. If you
Like
That wouldn't
Three
work.
lines.
If you did a backward C, it would make a circle.
yeah,
no, like
you have
no,
a square.
like digital C.
C. Wait, what did you say?
Yeah, it would be digital C.
Wait,
Yeah, with lines.
It would be like half a it would be like half a circle, a digital circle on a clock, right? You see a
Yeah,
digital circle on a
yeah,
clock, right? It would be that. You would have to
Yeah,
do half of that.
Yeah, so a backwards digital C type of
Yeah.
So that's a bad.
Or a half rectangle.
Yeah.
Half a square actually.
yeah,
Oh yeah, half a square.
because it says a square shape.
Yes. It's-
Yeah.
Yeah.
So yeah, we'll move on to question 8, which will be done by Varshatat. Hello, Varshita. Okay, let me just click on a button here.
Wait, what?
Something's happening. Okay, so let me just.
Yeah, that's better.
What's that gray stuff on your screen?
Oh, that's nothing.
Okay.
Okay, okay. A will be done by me. Just look at the pattern. It is made up of different shapes. Find some symmetrical shapes in the pattern. Here are some examples. Okay, so yes, that is one example, and you can also split this board in half with vertically and horizontally. And you can also nope, you cannot do that. Um yeah, that's basically all you can do. Yeah, so that's basically all you can do. So Anjali, you can do number 1 on the next page. Where my annotation? It's not everywhere. Okay. Anjali Keshav, you can do let's investigate. Hello, Anjali. Okay, just click on a button here.
He's muted.
I know, he's muted. So I'm just gonna click on a button here. Okay, Ishwar, you can do let's investigate.
Let's investigate.
Yeah, let's investigate.
Oh, what other shapes can you make? It's like half of it. You can make half of a diamond.
Uh, so,
Mm,
yes, you can do that, but it's not actually called a diamond. It's called a rhombus. It's basically a square that's tilted on its edge, on one of its edges. It's called a rhombus.
oh, a new one.
What? What happened? Okay. So, yeah, it's called a rhombus. So, what other shapes can you make? Because I know a lot. Ishwar, hello? Ishwar.
He's actually on mute.
I know.
I can't think of any more.
Okay, so you can do a square. You can also do. Oh, you have to join triangles together. Oh, okay. Okay, so I would say a rectangle because two triangles make a rectangle. And you can also do what's it called? So it has 1, 2, 3, 4, 5, 6. So that's a irregular.
Wait, can you make a square like 1.5 triangles?
with 1.5. It says what other shapes can you make by joining the triangles. So you can't.
Oh, okay.
So you can also make an irregular heptagon. Yeah, you can make an
Anyone talk?
Well, I don't know why everyone's so quiet.
Yeah.
yeah. Actually,
Yeah.
you can't do irregular heptagon because you can't use irregular over here. So yeah, those are basically the only ones. A square and a rhombus. No, I meant a kite. Is what I meant. Not a rhombus.
Yep.
It's called a kite, actually. Vocabulary. So vocabulary says polygon, a 2D shape with 3 or more right straight sides and angles. Quadrilateral, a four-sided polygon. Parallelogram, a quadrilateral with opposite length that are parallel to each other. Opposite sides are equal in length, and there are no right angles. Heptagon, a 7-sided polygon. Regular polygon. Polygon with sides of equal length and angles of equal size. Parallel. 2 lines that are the same distance apart all along their length. The 2 lines will never cross. Octagon and 8-sided polygon. So next page. Right here. Next page. This is the next page. Okay, right there. Let's see who's next. Johnny, you can do number 1, A and B.
Okay. So A is how many of the shapes are heptagons? Um, None of them.
Okay. I disagree because heptagons have 7 sides. So
I know.
here's one. I mean 7 sides, yeah. So here's one. Here okay. So one. So let's look at G first. We have 1, 2, 3, 4, 5, 6, 7. That's one heptagon. And then we have 1, 2, 3, 4. That's quadrilateral. So no. And then here's E. 1, 2, 3. 1, 2, 3, 4, 5. Nope. 1, 2, 3, 4, 5, 6. Nope. 1, 2, 3, 4, 5, 6. Nope. And 1, 2, 3, 4. Nope. And 1, 2, 3, 4, 5. Nope. So we only
So
have,
there's one.
yeah, there's one, which is G. So now, which shapes are hexagon?
Which have 6 sides.
Yeah.
So C is a hexagon.
C is a hexagon. Yeah. Yeah.
And D is a hexagon.
Yeah.
And that's it.
Yeah. I agree. So let's move on to 2A, B, and C, which will be done by Lochin.
Okay, so A, it has 4 right angles. The sides are not all the same length. Is it a rectangle?
No. Well, yeah. Yes, it is a rectangle.
Okay. For 2B, it has 2 pairs of opposite sides that are equal in length. It's a parallelogram.
Mm, yeah, I agree. Parallelogram. Yep.
And for 2C, it's a square.
It has 4 lines of symmetry. The angles are all right angles. Yeah, I agree. So next question is number 3 will be done by Neil. Hello, Neil.
Yeah, sorry about that. It says here are 6 shapes labeled A to F. A, B, C, D, E, F. So, like, do I have to give out the names of those shapes?
It says copy the table and enter the letter to show the properties of each shape.
Okay, so for one, has at least one right angle, only one pair of equal sides. So if it has at least one right, I would say, and one pair of equal sides, I would say it's like maybe B.
No. Well, no. Because B with one pair of equal sides and at least one right angle. I really don't know. I thought it would be D because it has one pair of equal lines.
No, D has 2. Oh wait, one pair. Wait.
Wait.
Oh, it
I
has
agree.
2.
Yeah, I agree. I agree with B because D has.
Yeah, because D has 2 because one at the top and bottom and then one left to right.
So
Yes.
yes,
D has 2.
so B is
The B has at least one right angle and only one pair of equal sides.
yeah.
Okay, so